In this video, we are going to study about the chemical properties of metals and nonmetals. We'll start with the chemical properties of metals. Metals are electropositive in nature, which means that to become stable, they lose electrons and form cations. So here in these metals, they have lost 1, 2 or 3 electrons and they have formed cations. Before we move to rest of the properties of metals, we need to understand this reactivity series. It is a list of metals which are arranged in a vertical column according to their decreasing reactivity, which means that metals which are at the top of this series are most reactive. As we move down, their reactivity decreases and at the bottom, least reactive metals are present. Now these are the symbols of the metals and this is the technique which will help us to remember this activity series. So I'll quickly read it out. It is कालू नाथ कलकत्ता में आलू जीरा फिश पकाकर हाइड्रोजन के साथ कोचीन होकर आगरा आए. So you can note it down so that you can remember the activity series. We will now discuss rest of the properties of metals using this activity series. So first we are starting with the reaction of metals with air or oxygen. All the metals react with oxygen except a few which are at the bottom of the activity series. Rest all react with oxygen to form their oxides. And we can see that this is a combination reaction. Though the rate of reaction vary as we move from top to bottom. At the top, potassium and sodium reacts violently with oxygen, so they have to be stored under kerosene and we can't keep them in open. Rest of the metals keep reacting with oxygen slowly and form an oxide layer on them. As a result, these metals slowly lose their shine. Oxide layer formed on magnesium, aluminium and zinc is sticky in nature and it sticks to the surface of metal, protecting the lower layers of metal. While the oxide layer on iron is non-sticky and flaky and it falls down, as a result exposing the next layer of iron. In this way, whole of the iron is eaten away. Aluminium oxide layer formed is quite inert. As a result, a thick layer of aluminium oxide is used for coating some other metals like aluminium or iron by the process of electrolysis. Because this layer is formed at anode, that is why it is given the name anodizing. Advantages of anodizing are that they protect the aluminium articles from further corrosion. They also protect iron articles from corrosion. Apart from that, this oxide layer can be easily dyed or colored to give it an attractive look. Now these oxides which are formed by the reaction of metals with oxygen behave as basic oxides. It means that if we react them with acid, they will give us salt and water and there will be neutralization reaction. So we'll see in this activity series, potassium, sodium, calcium, magnesium, when their oxides will react with acid, they give salt and water. It means they are behaving as basic oxides. But the oxides of aluminium, zinc and iron, they behave as amphoteric oxides. Amphoteric oxides are those oxides which react with acid as well as base to give salt and water, which suggests that they are behaving as acid also or base also. So we'll take the examples of these three oxides one by one. First of all, we have taken the example of aluminium oxide. Aluminium oxide, when reacted with acid HCl, it gives salt and water. When it reacts with base NaOH, it gives salt and water. So let's see the names of the salts also. With acid, it is giving aluminium chloride and water. With base, it has given sodium aluminate and water. You need to write these equations at least 4-5 times so that you can understand them better. Now we will take the example of second amphoteric oxide, which is zinc oxide. Again, it will react with an acid to form zinc chloride and water. With base, it will form sodium zincate and water. So in both cases, it has formed salt and water to give neutralization reaction. This suggests that aluminium oxide and zinc oxide, they behave as amphoteric oxide. Now I suggest that you write the reactions of ferric oxide with hydrochloric acid and with sodium hydroxide. You can pause the video here and write the reactions with acid as well as base. And just for your hint, You can see the formula of ferric oxide is exactly same as that of aluminium oxide. So the formula of their products will also be exactly same. So pause the video and try to write the equations. So these are the equations of ferric oxide with acid and base, and I hope you have got them right. We move to the next property, reaction of metals with water. Metals like lead, copper, mercury, silver, gold, they do not react with water, and rest of the metals they react with water, but their reactivity varies. Out of these metals, we have to remember about magnesium. Magnesium reacts with hot water, and all the metals which are above magnesium, they will react with cold water, and the metals below magnesium will react with steam. So if you remember about magnesium that it reacts with hot water, rest of them you will be remembering easily. Now the second thing that we need to understand here is that these metals from potassium to magnesium, on reacting with water they form hydroxides. Rest of the metals they form oxides. Actually these metals also form oxides, but as soon as oxides are formed they again react with water to give us hydroxide. So these metals have been divided into two groups. One group gives hydroxides with water, other group gives oxides with water. And there is a task for you all now. You need to write the reaction of all these metals with water and then reaction of all these metals also with water. I have given one sample for each group. Sodium reacts with water to give sodium hydroxide. Similarly, magnesium will react to give magnesium hydroxide and hydrogen. And from this group, aluminium reacts with water to give oxide here, that is aluminium oxide and hydrogen, and iron will give iron oxide and hydrogen. So you need to write the reaction of all these 7 metals with water. The question that we are going to discuss here is what will happen when these metals are dropped in water. Now potassium and sodium are highly reactive and they react violently. So first we will discuss these two. So as soon as we drop potassium or sodium inside water and they touch the surface of water, the reaction starts and they will catch fire. Now the reason is that this is a displacement reaction because sodium will displace hydrogen from water and all displacement reactions are exothermic. As a result, the hydrogen gas which is produced will catch fire and sodium will also start burning. So the color of the flame will be golden yellow. In case of potassium, the color of the flame will be violet. So both these metals on touching the surface of water react and they will catch fire. When we drop calcium and magnesium, which are not so reactive, as a result, the reaction is not that exothermic. So first they will go and settle at the bottom because they are heavier. Reaction will start, bubbles of hydrogen gas will be produced. These bubbles will stick to the surface of the metal piece, make it lighter, and after some time we will see that the piece of metal will rise up and start floating on the surface of water. Next is the activity which shows the action of steam on the surface of metal. We have taken a hard glass test tube here in which metal sample has been taken and a glass wool soaked in water is kept here and it is heated. Steam will be produced which will pass over the metal sample, react with it and will produce hydrogen gas. This hydrogen gas will pass through this delivery tube and will enter into the gas jar which is full of water. We will be able to see the formation of bubbles and we will see that level of water starts falling down because the hydrogen gas is being collected by the downward displacement of water. Next property of metals is their reaction with dilute acids. These metals do not react with acids while the rest of the metals react with acids with decreasing vigor as we move from top to bottom in the activity series. Now the metals when react with acid will displace hydrogen and form salt and hydrogen gas. That suggests that it is a displacement reaction and it will be exothermic reaction also. So I have given here two examples. Potassium with hydrochloric acid forming potassium chloride and hydrogen. Similarly, aluminium forms aluminium chloride and hydrogen. We can see the reactions with other acids like sulfuric acid also. So zinc on reacting with sulfuric acid will form salt zinc sulfate and hydrogen gas. Now there is one exception to this which is nitric acid. Nitric acid on reacting with metals does not give us hydrogen gas. The reason is that nitric acid is a strong oxidizing agent, and as soon as hydrogen gas is produced, it is oxidized to form water. And nitric acid itself gets reduced to form oxides of nitrogen. So in place of hydrogen we get water, and along with it we get nitrogen oxides also. So the products of reaction of metals with nitric acid will be a salt, water and nitrogen oxides. There are two exceptions for this also. There are two metals like magnesium and manganese. They will react with nitric acid and give salt and hydrogen. This is an activity that shows that different metals at different positions in the activity series, they react with different vigor. So here we have taken 5 test tubes, and all 5 we have taken the same acid with same concentration. So let's say we have taken hydrochloric acid in all the 5 tubes, and we have put magnesium, aluminium, zinc, iron and copper in these 5 test tubes. As soon as we put the metals inside the acid, the reaction will start, and we will see the formation of bubbles in these 5 test tubes. So we will notice that in this test tube, the amount of bubbles or the number of bubbles will be maximum, and in this test tube it will be minimum. So this will suggest that these metals have different reactivity. We can easily compare between magnesium and iron, but if we are asked to compare between zinc and iron, it will be difficult because there will be too little difference in the formation of bubbles. So we cannot clearly say which one is more reactive and which one is less reactive. Another way to compare their reactivity is note their temperature. We can put the thermometers in all the 5 test tubes and note the rise in temperature. So we will see that maximum temperature will rise in test tube A and minimum temperature will rise in test tube E. So we can just get an idea of the reactivity by reacting metals with acids. Most of the metals react with acids except a few that lie at the bottom of the activity series. For example, noble metals like gold and platinum, they do not react even with concentrated acids, but they do react with aqua regia. Aqua regia is a mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1 by volume. This aqua regia is also called as royal water, and it can dissolve gold and platinum inside it. This property of aqua regia is used by many people to dupe others. On the pretext of cleaning their gold ornaments, they dip it inside aqua regia so that the outer layer is removed. Now people think that their gold has been cleaned because inner shiny layer comes out, but actually they lose whole of the outer layer from their gold jewelry. Next property of metals is their reaction with the salt solutions of other metals. It is also a type of displacement reaction. Here we have taken a metal and the salt solution of another metal, zinc. Now because aluminium is more reactive than zinc because its position is higher in the reactivity series, so it can displace zinc from its salt, takes its place to form aluminium chloride, and zinc will come out of its salt. Another example is when iron nails are dipped in copper sulfate solution, which is blue in color. After some time, ferrous sulfate is formed and copper is displaced. So blue colored solution will change into pale green colored solution, and there will be deposit of copper, which is reddish brown deposit on the gray colored iron. So we will be able to see these color changes to know that displacement reaction has taken place. Now this reaction is a sure shot method to know which metal is more reactive and which is less reactive. For example, if we'll take copper and react it with zinc, we see copper is placed lower and zinc is placed higher. So means zinc is more reactive. So copper cannot displace zinc from its salt solution. Now there is this activity. In this, two test tubes are taken. In one of the test tubes, copper sulfate solution is there and we have dipped an iron nail. In second, iron sulfate solution is taken and copper wire is dipped inside it. Now can you tell what will be the products formed in these two reactions? I hope you have guessed it right. Iron plus copper sulfate will form copper and iron sulfate because iron is more reactive, it has displaced copper. But copper is less reactive, so it will not be able to displace iron from its salt solution. Now, reactivity series has been made on the basis of this displacement reaction of metal with the salt solutions of other metals, because it is a sure shot method to know whether the reaction will occur or not and whether the metal is more reactive or it is less reactive. So we'll again see what reactivity series is. It is the arrangement of metals in a vertical column in the order of their decreasing reactivity, and it is made by knowing the relative reactivity of metals on the basis of displacement reactions with salt solution of other metals. Now, reactivity series cannot be formed by comparing the reactions of metals with oxygen or water or acids, because for two reasons: all metals do not react with these, and number two, it is difficult to measure the speed of these reactions, as we have seen in case of reaction of metals with acids. Now, another thing is that hydrogen, which is a non-metal, it is kept in this activity series for the reason that just like metals, it can also lose electrons to form the cations. We will now study the chemical properties of nonmetals. Nonmetals are electronegative, which means that they gain electrons to form anions and become stable. So these three examples I have given: chlorine gains 1, sulfur gains 2, and nitrogen gains 3 electrons to form anions and become stable. Just like metals, nonmetals also react with oxygen. But unlike metals, they do not form basic oxides, but nonmetallic oxides are either acidic oxides or they are neutral oxides. For example, carbon dioxide is an acidic oxide. Sulfur dioxide is also acidic oxide. But water and carbon monoxide, they are neutral oxides. Carbon dioxide is an acidic oxide because it combines with water to give carbonic acid. Sulfur dioxide combines with water to give sulfurous acid. So we see that non-metallic oxides are either acidic or they are neutral oxides. Nonmetals do not react with water or acids, but they react with salt solution of other nonmetals. So just like metal reactivity series, there is a reactivity series for nonmetals also. Now fluorine, chlorine, bromine, iodine are arranged according to their reactivity. As chlorine is more reactive than bromine, so it can displace bromine from its salt solution and takes its place. So sodium chloride is formed and bromine comes out of its salt solution. Nonmetals behave as oxidizing agents because they have strong tendency to accept the electrons. Fluorine, oxygen and chlorine are strong oxidizing agents. Now we have discussed all the properties of metals and nonmetals, and we are in a position now to answer this question. Differentiate between metals and nonmetals on the basis of their chemical properties. You can pause the video and think about the answer, and then check your answer from this table.